Hi guys, this is Mohammad P, a tutor on Chegg.com. So today we are talking about determinants. Determinant is basically kind of evaluating a matrix. I would start with the 2 by 2 determinant, and I am gonna expand it in like 3 by 3 or 4 by 4. Okay, let's just start with something like, let me write a general formula for this first. So assume that we have a matrix A, B, C, D. And I would like to take the determinant of this matrix. The general way that they show the determinant, instead of writing that, it's basically putting two parallel lines, not brackets. So A, B, C, D. So for a 2 by 2 matrix, the way that it works, you multiply A and D together, so AD, and then you subtract the multiplication of the other diagonal, which is BC. And that gives us the value of the determinant of the matrix that I wrote. For 3 by 3 is a little bit complicated as the order goes higher, like 4 by 4, 5 by 5. So the way it's a little bit more complicated that I'm going to show you. So let's just start with the example of 2 by 2, and then we are going to move on to the 3 by 3. So the example for this is like 2, 5, 6, 7. So it's going to be 2 times 7, which is 14, minus 5 times 6, which is 30. And then 14 minus 30 is going to be negative 16, and that's the value of the determinant. So the determinant can be 0, can be positive or negative numbers. The key idea of the determinant is that you need to be careful that your matrix is n by n. So it cannot be like 2 by 1 matrix or 3 by 5 matrix. So it has to be like completely a square matrix. The number of the rows must be the same as the number of the columns. Okay, so let's move on to the 3 by 3 matrix. So let's say I have A 1, 1. I'm going to write it a little bit more formal. A 1, 2, A1, 3. So the first number represents the row and the second number represents the column. So A11 is the element of the first row and the first column. A12 is the element of the first row, second column, and similarly A13 is the element of the first row and the third column. And I'm gonna use different, not different, let's keep the A. So it's A21, A22, A23, A31, A32, and A33. Okay, so the formula that I'm gonna use to evaluate any higher order than 2, it's gonna be like this. I'm gonna choose a row or column. It's arbitrary, so you don't really need to choose a specific one. I prefer to go with the first row. So I'm going to choose either a row or a column, and then I'm going to expand the determinant about that. So by expanding, I mean that you start with the first element in the row or the column that you chose. So I'm going to write A11. So this is basically equivalent to, so A11, then I'm going to write negative 1 to the power. I'm going to write the power as the sum of the row and column of that element. So it's 1 plus 1. Then I multiply by a determinant, that this determinant is going to be obtained by canceling the row that you chose and the column corresponding to that first element that we are working on it. So I'm basically canceling this and canceling this. So I'm going to write A22, A23, A32, and A33 here. So I'm going to just remove these. So I'm going to have A22, A23, A32, and A33. Okay, so we are done with this. I'm going to go and add. Now I'm working on the second element, A12, negative 1 to the power, sum of the row and the column of this, so 1 plus 2. And then, now I'm going to multiply it by the determinant obtained by canceling of that row and these column. So I would write A21, A23, A31, and A33. So I'm going to remove those lines. So I'm going to write A21, A23, A31, and A33. And similarly for the last one, A13, negative 1 to the power of 1 plus 3, and then the determinant here, the determinant that goes here is obtained by canceling this row and this column. So I'm going to get A21, A22, A31, and A32. And you know how to calculate the 2 by 2 determinant as I explained on page 1. So just multiplying these diagonal and then subtracting these diagonal. You do the same thing for all these 3 determinants. And then by doing the algebra, you can figure out the result of the determinant. So let me show you an example for 3 by 3 determinant. So let's consider 3, 1, 0, 5, 8, 1, 6, 2, 0. Okay. So I choose a row or column. Let's, in order to show you a little bit different way, I'm going to choose the first, or no, let's make it a little bit more different. It's better to choose a row or column that has the most 0. Why? Because the elements that you are going to write at the beginning and multiply by negative 1 and the determinant, if those elements are 0, it simplifies your work and it's way faster. So if you see I have a column with 2 zeros, it's better to choose this one rather than choosing second row, because in the second row if you choose 5, 8, 1, none of them are 0, so you have to do more work, you need to do more calculation. But if you choose this third column, 2 of the elements are 0 and it simplifies your calculation. So here I'm going to choose the third column. So, and I'm going to expand about that. So the first element here is a 0 times negative 1 to the power. That's the 0 position is the first row and the third column. And then multiply. So if I cancel the first row and the third column, I'm left with the 5, 8, 6, 2. But when you get more advanced, you don't really need to think about this, because when you see that 0, you don't care about the rest. You say, okay, the first part is going to be 0. And then you go to the second part. The second part, it's 1 times negative 1 to the power of, so this is the second row and the third column, so it's 2 plus 3. And the determinant obtained by canceling the second row and the third column, it's going to be 3, 1, 6, 2. And similarly for the third part, that's again 0 times negative 1, that's a third row, third column, so 3 plus 3, times, if I cancel the third column and the third row, I would left with 3, 1, 5, 8. Okay. So obviously we can say that part is 0 and also this part is 0. So the only thing that I'm left is this part, the middle one. Negative 1 to the power of 5 is negative, and then the determinant here is a 2 by 2, so 3 times 2 is 6, minus 1 times 6, which is 6, and interestingly is going to be 0. So the determinant is 0 in this case. Okay. That's basically it. You can do the similar thing for 4 by 4 or 5 by 5. That's the same procedure that I showed as 3 by 3. I hope that all you guys enjoyed this and learned enough. Please wait for the future videos. I'm working on more topics in future, and please follow me. You can actually message me if you want on the link provided. And I wish you the best and have a wonderful day.